Oh,
I don't feel awake enough to do this.
good.
High energy 203 incoming.
I'm assuming this is your episode.
It is. That's true.
Because I don't remember making these slides. It is possible that happened.
Do you remember seeing them?
I do remember seeing them.
Because we've done this before.
We certainly have. Second time round. I'm going to try and act as, stupid as I did in the first episode.
I mean, knowing you that your memory is basically completely defunct at this point.
Absolutely.
I feel like this will be a whole new experience all over again.
Yep. Yep.
So making new
Looking
friends every
forward to
day. We did a video. Now it feels like eons ago about color spaces.
Yes, absolutely.
And someone in the comments said it was the least wrong video on color space, and I'm like, you know what? That's the bar I'm going to strive for today as well.
Okay.
I'm probably not going to manage because there's more. There's more on color spaces that I want to talk about. But if you haven't seen it, if you haven't seen it, you should go back.
I mean, I saw it. I don't know. I was there.
Did you see it? Or did you just record it?
There's proof that I was in the room.
It is.
And I nodded along.
You see, did you pay attention? Who knows?
Well, let's find out.
Let's find out. So, color spaces. We talked about this. Again,
Yes.
if you don't know what this diagram means, it's all in the previous video.
Srgb in the smaller one.
Smallest triangle, yes.
P3,
Yes.
slightly bigger. Rec 2020.
That is correct. And the, well done, have a cookie after we're done.
Thank you.
So the curvy bit is a representation of the XYZ color space, and inside this colored bit, those are all the colors a human can see.
Yes.
And so these triangles form a subset of these colors that humans can see. And the whole XYZ space was modeled through humans matching colors. So basically, it tells you what happens when two colored lights mix. How do we, as humans, perceive that?
I love these graphs like this because they're kind of a joke. Because outside the biggest triangle there is a load of colors that screens can't represent, which people are viewing this on a screen.
Yes. So the colored in bits are
a lie.
Yeah.
Yeah.
Kind of roughly. That's like that. Those are green colors, different green colors, but green, and the blue colors, similar.
OK.
You usually see these because display P3, sRGB, Rec 2020 are about display device capabilities. And as you may know, we have little pixels in red, green, and blue, which emit light. And then this light mixes inside our eye almost, and we perceive a color. So these triangles represent which colors these devices can actually create by mixing the pixels and which colors they cannot.
Yes, and people at home are probably watching this on. I mean, one of the two inner triangles, I'd say. It's less common to have a computer display, which is Rec 2020.
But even then, our video will most likely just prescribe sRGB anyway.
Yes.
So that's another layer of confusion that, even just because your monitor can display Rec 2020 doesn't mean it will, because if the media that is input into the device says, hey, I'm using sRGB,
yes,
it will be sRGB.
Yes, we're an sRGB series.
Yes.
HTTP sRGB.
Exactly.
Cool.
That's the S in HTTPS. So these three color spaces, as you said, sRGB, P3, and Rec 2020, are actually available in CSS now.
Yes.
So far, by default, everything in CSS, everything on the web pretty much was sRGB. But it turns out, people who like colors want access to the other colors that are outside of the sRGB triangle. And so now we have this syntax to do that, which is already kind of exciting that we have more colors. So all these color spaces are about giving you access to more colors. And Safari actually has support for this. Like in Safari TP, you can use these syntax and actually have this cool color picker thing where you actually see whether the fancy color you're selecting is inside or outside the sRGB gamut.
Oh, that's nice.
So you can see we actually don't get many new blues, but some new reds and a lot more greens you get when...
Way more greens. Look at that.
Yeah,
Whoa.
So much green. Incredible. And it kind of matches with the triangles we saw earlier. So there's going to be a lot of Safari in this episode because it will be implemented in Chrome, but it's not even in Canary yet. So we can't.
Credit to them for trailblazing
absolutely.
this.
It's great.
Absolutely.
Absolutely great.
When you say not equivalent, what does that mean?
So I turned the first color, sRGB 100, is as red as possible in sRGB.
Yes.
We have just seen that display P3 has more red. So
Ultra
going
red.
full red in display P3 is a different red than the red in sRGB.
Yes.
I could have put the equivalent number in there, but that would have been work that I didn't want to have to do.
XYZ is the one which is all possible colors.
And more.
And
So
more.
I
So if
actually
you put a 2 in there, what happens? Does the red come out of the monitor and just there's so much too much red to even contain within the screen?
Even XYZ100 is a color that doesn't exist.
Brilliant.
So that is actually we'll talk about later. What does a browser do when you give it a color that it can't display or that potentially doesn't even exist?
Full crash.
Yeah, just like panic.
Delete itself. Yeah. Otherwise, it would break the universe. And
Yes, we need to
be
be backwards compatible, right?
Absolutely.
Exactly. So as I said, like we have these color spaces which are about giving you access to more colors, but it's all just a subset of XYZ. There is also different perspectives onto XYZ. Most notably LAB and LCH, and we're going to talk about these now a little bit to explain how they're different.
So some of these are available in Chrome, right? Well, so there's the other one that's not RGB that we use, which begins with an H, HSL.
HSL.
So is that one of these perspectives?
HSL, no, yeah, no. HSL.
No, yes, no. No, that's great. Brilliant explanation. Just move on.
I went Australian and then added another. No, it's HSL is just a different perspective onto sRGB. So it is has the same constraints. Like you don't get access to more color by using HSL, but it is the same switch of perspective. Like that you go from a Cartesian coordinate system where each axis is a color to something that has an angle and stuff.
Which you do with HSL, right? Like
exactly.
Yeah. Okay.
And this will actually happen here. So LAB and LCH are interesting because they are perceptually uniform. Great keyword. So all of these are...
You don't need me. You're just congratulating yourself. Well done, Surma. Great keyword. OK.
Well, the thing is, I see it thrown around so much, and it seems self-explanatory to people who already know what it means. But if you don't know what it means, it's not self-explanatory.
I don't know what it means.
So I'll explain it to you.
Thank you.
So all of these color spaces, all of the XYZ stuff is perceptual because it is based on humans perceiving colors and modeling a space around how humans perceive it. Like you match colors and like, oh, this is orange. I perceive it as orange. And that's how XYZ was made. But it's not perceptually uniform, which means that you have one color and you add a bit of red to it, and then you add the same amount of red to it afterwards. That doesn't mean you will see it as a linear increment of redness in the color. Like the uniformity isn't there. That like it could actually turn a completely different color technically. But it's like XYZ and all the subspaces are about how light mixes and how humans perceive that mixed light.
Right. So the idea, if you double the amount of red, you as a human would look at it and go, that looks like twice as much red, even if it might not be.
No, yeah, no, that's actually not the case with XYZ. So because
yes, but with these ones,
with LAB and with such uniform space, that is the case. Especially around lightness, where you go, hey, I want to double the lightness. You double the number, and you get twice as bright a color, which is obviously very important for, intuition around colors and when you pick your palettes and stuff. So let's start with LAB. This is the Srgb gamut inside LAB. So every colorized pixel in this graph is a color that is inside RGB, sRGB. Every pixel that's outside of these is technically still a color, but at least not inside sRGB.
Okay.
But just like XYZ, there's also coordinates that aren't even real colors. So that can be a bit confusing. You can actually come up with coordinates that don't represent any real color in the real world, and it's just pointless in a way. So LAB has 3 coordinates, L, A, and B, hence the name. L is for lightness, is between 0 and 100. And as I said, such uniform. So if you go from 100 to 50, it's half as bright because it's half the brightness value, which is quite nice. A is the red-green axis. B is the yellow-blue axis. It's not very intuitive. I'm not going to lie. But it is one of the first perceptual uniform color spaces. So here, for example, we're getting a 40% brightness. On A, we're going to -50. As A is the red-green axis, this is a nice green tone as rendered here by Safari.
Nice.
So, but again, I feel like this is not necessarily very intuitive to use. But as a rule of thumb, both the A axis and the B axis go from I think, minus 130 to plus 130 to cover the human gamut.
Right, OK.
So,
Yeah.
But then again, covering the human gamut doesn't mean that your screen can actually create that color with their pixels. So while you might have a real color, it doesn't mean that it's actually a useful color on the web, because
I guess I'm laughing at it being 130. It's like, why is it that? But
magic number out of a hat.
Yeah, but we're used to using like 255,
Yeah.
like for which, you know, if you show someone outside tech that, it's like, well, where did that number come from? That's something they just made up. OK, OK, I'll get over it.
I'm not sure where this comes from. I think it's just a number. Just deal with it.
All right, I'm dealing with it.
So let's talk about LCH. So LCH is the HSL of XYZ.
I want to see this in a museum. Is there a museum where there's this
It
rock?
actually does look like a nice sculpture, doesn't it?
Is this how it was invented? Did someone dig up that rock?
Almost like
And it was
color
like,
spaces.
I found the color stone. And it's in a glass thing,
It does
rotating
look like
around.
it, right? So
Yeah.
I will say I don't find this visualization very helpful. It's from
Good, 'cause neither
Wikipedia,
do
but
I.
I had to put something on the slide, OK?
Yeah, it's very pretty, though.
It is pretty. So LCH is the same thing as HSL in that it has an angle and the lightness, and the third axis here is chromaticity. It's more intuitive because, you know, we kind of get used to like 0 degrees is red and 120 degrees is green from HSL.
Yes.
Those kind of things we kind of know.
Is it the same here? The same
It
degrees?
is exactly the same.
Okay.
The only thing that's weird is that the value you can use for C, as you can see here, depends on both other values. Like at 0, you're obviously black. At 100, you're light. But in the middle, like you can sometimes go with chromaticity to 130. Sometimes you can go only to 20. And again, it is quite easy to fall outside the gamut with LCH. But it is a bit more intuitive to use. So again, we can 50% lightness, 80 chromaticity, 0 degrees is a nice, vibrant red. A bit pinker here because chromaticity is, again, can change actually what we usually perceive as hue because of human eyes.
And when you're saying like you can fall outside the gamut, that would be the Srgb gamut, right? Like
yes.
That is the.
Well, you can even fall outside the P3 gamut or physical real-world color gamut.
Amazing.
All of that is possible. And it's actually a good question. Like, what happens if we give something that is outside the gamut? And we'll talk about that a bit later.
Oh, I was going to try and guess.
Well, the first thing that's already weird is that there's actually a thing in the spec that I think is quite stupid. Because if I were to, instead of 50% lightness here, say 0% lightness, what would you expect?
I mean, I would expect it to be black.
0% lightness, right? It should be black. Currently, Safari does this. It gives you a dark red.
No. Why?
Stupid.
OK.
Actually, let me explain to you why it is.
OK.
But also give you hope in that the CSS working group agrees that this is stupid and they want to change it.
All right, all right.
But I mentioned in the last video that XYZ is the common denominator, the one that we use for conversion from one color space to another. Instead of like, going straight from color space A to color space B, every conversion goes via XYZ. It's like the source of truth color space to convert between all the color spaces that are out there. And that's exactly what Safari is doing. So we define LCH with, or we give a color defined with 0 lightness, 80 chromaticity, and 0 hue. And then they just look up the formula for how do I convert from LCH to XYZ. And that's just straight up math. This is what comes out the other side.
OK.
And then they look up math. How do I go from XYZ to Srgb? And that's what comes out.
No.
And there's a negative number, which we know Srgb doesn't do. And so how Safari currently handles that, because how you should handle it is unspec'd effectively, it clamps. It looks at every component and says, hey, you're outside. Go between 0 and 1. And so that turns into a darkish red.
Right, whereas I guess a proper operation would be to shift by some amount, which would end up with 0.
It's actually quite hard to figure out how to describe what you should do. But Leah Veru and Chris Lee have actually a really good website called css.land/colorpicker? LCH.
We'll put a link in the description.
We'll put a link in the description. And you can see, like, once you go to lightness 100, every color is white. If you go to lightness 0, everything is black. And they have dug up an algorithm that handles this correctly. And this is most likely what is going to be added to the CSS color spec so that we don't get a dark red when we just specify 0% lightness.
Good.
So
Thank you, Leah and Chris.
That will probably be changed and fixed soon. What's also quite nice, actually, I found that in the CSS color 4 spec, there is actually a reference implementation of all these color conversions in very readable and simple JavaScript. It is mostly supposed to be red, but it does work if you want to programmatically.
Red as in, hang on. That's an overloaded term in this video. It's mostly supposed to be viewed with your eyes.
With the eyes,
Yes.
consumed as text.
Yep. Okay.
It's very clearly written, so you really see how do you do all these conversions, how do you define the color's luminance. If you want to do color operations programmatically, Leah also maintains color.js, which is a library that has all of these things baked in with more performance and actually a nicer API. So that's something worth looking at.
I'm really happy that they've done this because I've been reading some compositing specs and stuff, and it's written in maths, which I don't understand. I don't understand the symbols. I find it hard to deal with like these one-letter values and stuff.
Here's a big sigma.
Right. Yeah. I was like, thanks. I'll take it. No, and then being able to, just find. Well, that's what I've been doing with this compositing stuff. Is going and finding a implementation written in C or as a shader or something. That's like, oh, now I can understand.
We know code. We can read code. Don't do the math. Give me the code.
Exactly. So this is great.
And also very well commented. So definitely worth a look. Let's talk a bit about how to mix colors, because we've been talking about mixing light. But CSS actually doesn't do that as of now. Because let's say we have red and blue. What is the color in the middle?
You're right. What one? Yeah.
So the
1, 2, 7 of each, right? Like
exactly. So that's basically you look at each component. Like R is one component, the R value, the green value, and the blue value, each called components, and you just you have them. Like what's in the middle between 0 and 255, and you do it per component. And the same you do if you want to do like a 75-25 weighting. So you could do 192 and 64, and the same the other way around. And this is how color mixing works in CSS, and it's actually also how gradients work in CSS.
Right.
So and now you can tell that actually when you do it just per component, the color space in which you define a color has a huge influence on what the output of mixing is. Because in RGB it's RGB, but in HSL it is H, S, and L that are now being looked at independently. And a different color will come out of the mixing process depending on in which color space you want to mix. And that is something they're now adding to CSS, where you can say explicitly, I want to mix these two colors. I want to mix them in a certain weight. And the mixing should happen in this specific color space. So basically, this says mix these colors in sRGB, which is the default anyway.
Yes, which is the one we just saw before.
But you can basically define, I mean, display P3 doesn't make sense because it's effectively just a subset of XYZ. But you could put LAB or LCH or something in there. Define your colors in one space and mix them in another.
So it's when we're saying sRGB there, the values it takes are not just the gamuts, it's also the perspectives on those gamuts.
Yeah,
okay.
Exactly.
Can you do both? Because can you say, well, I guess there's no real such thing as lab in sRGB, is there?
Well, you can basically define your colors. The way you define the color is completely independent of where you're mixing. Instead of just writing red, I could write color display P3 or LAB or LCH.
I see.
So you define the color in one color space, and then for the mixing, CSS will convert however necessary to do the mixing appropriately.
So in the last episode, you identified how gradients were.
Hold on to that.
All right, I'm holding on.
So color mix is the result of the color mix function is a single color, which is good. That's handy. For gradients, we don't have a syntax yet. They are thinking about adding something like this, and an additional syntax where you now also say, I want the gradients to be mixed in a specific color space.
Brilliant.
Hasn't been spec'd yet. So for the purposes of this demos, I've just been creating 255 divs next to each other and assigning a new color to each. So we can talk about how this color mixing really affects gradients and the color mixing process. So you might remember this from last time. I'm mixing red and green. And as you can see, the color space I choose is quite important. We talked about last time, in sRGB, you dip to this darkish yellow blurpy color that's actually not really nice.
So you mentioned last time that doing things in linear color is that XYZ?
That is basically XYZ, which is.
I see.
And you can see it looks nicer, but actually you go away from red really, really quickly.
Yes.
LAB, very even, very nice. And LCH, almost the same. I personally actually like HSL the most. Even though it's neither uniform brightness nor is it's just you rotate the hue. But actually, I think looking at this, I like it the best.
What I really like about this syntax is, if you go to an article about linear gradients in CSS, one of the examples that will come up with is a rainbow.
Yeah.
Right. And the way they'll do it is by having like a load of points.
Yeah.
But I think you're saying here is that you would be able to do this with 2 points.
Yeah. You go from
like 0, 360.
You go from 0 to 360, and it would go all the way around the color wheel and keep everything constant. And that's actually really, really nice, right?
That is really, really nice.
So yeah, this is the red-green comparison, where I think there are some differences, but overall it looks fairly similar, like not a huge difference. If we look at red and blue, it gets a bit more different. Again, I actually feel like HSL looks the best, although LCH also looks quite nice.
I think it will depend on what your I'm
goal is.
about to say something obvious. Yeah, it depends on the visual effect you're going for.
But I think it's interesting because as far as I know, most design tools don't allow you to choose yet which color space you want your gradient in. But it will become a design choice, because I don't think there's a clear winner. It really depends on your use case which color space interpolation looks best for what you're going for.
Yes, I think we can all agree that the sRGB one is not very good.
No.
But the rest is kind of like, well.
Well, now hold on, because we've just been mixing primary colors, like pure red and pure blue, pure red and blue.
Poo red, poo blue.
We've only been mixing.
Mate, if you have blue poo,
that's an issue.
You're a Smurf.
So we've only been mixing primary colors, so pure red, pure blue, or pure red and pure green. Let's mix non-primary colors, because things will get wild. How about yellow and blue?
Wait, hang on. These are very different.
These are very different. So I think we can still agree mixing sRGB looks sad.
Yeah.
XYZ, technically uniform brightness across, but not necessarily what I was going for. I think if I imagine going from yellow to blue, I wouldn't expect an almost white in the middle.
All of these are wrong.
LEB,
I don't like any of them.
Right?
Take them back.
LEB is LCH and HSL.
LEB is not good. It's kind of weird purple in the middle that I wouldn't expect. Okay.
That's a different statement. I like LCH and HSL. They're not what I expected, but they're pretty.
Yes, that is fair.
They're colorful. They're trip.
Yeah.
So it's like I don't even know which one I prefer here. But again, I think the same advice applies. It depends
what you're doing.
What are you trying to achieve in your design?
Yeah.
So I think it's just really interesting that for me it kind of became clear that for gradients, the color space in which you interpolate is part of the design choice and something that needs to be shared with the developer that implements the gradients, because it will look wildly differently otherwise.
Yes.
Adam's favorite is doing blue to white or blue to black, because if you look at sRGB, it's really hard to unsee once you do it. It actually dips to a bit of purple.
Yes, it does.
Along the gradient. And you usually don't want that when you go from black to blue. And so his the method of fixing it in sRGB is like to add, as you said, like an additional stop that counteracts the purple shift. I mean, LCH and HSL just go full purple on you.
Yes.
And so again, you can see it all looks different, and people just need to start working with these gradients in a bit differently. It's really interesting to see.
Yeah. So the reason that sRGB is not great in any of these examples is because, yes, it's like all of them linearly interpolating, but the values in sRGB are not actually linear.
No, they have this gamma correction on top, which stems from CRT monitors, but is coincidentally also kind of how our eyes adapt to brightness.
Yes.
So it's a happy coincidence, but it doesn't work for color mixing and stuff. So most of the time when you operate on colors, you kind of need to remove the gamma correction, and that's called linear sRGB, or XYZ, which is actually, in this sense, then in this scenario, fulfills the same purpose. All right, one last thing I want to talk about. Did you notice that HSL has a different text color than all the others?
I do notice it, yes.
Do you know why?
Because it would be hard to read otherwise.
It would be hard to read.
Is that why? OK, good.
And you know who made it color black?
It's you?
No.
No?
CSS chose the text color.
What?
Because that's a new thing now. There's a new function called color contrast, which you put in a color as a first argument, and then you say versus, and then you give a list of colors, and color contrast will choose the color which has the highest contrast to the first color.
Nice.
Fully automatically, which especially in the context of dark mode or color animations can be huge. It actually has an additional syntax where you can specifically define the WCAG contrast ratio
Oh, that's
And it will pick the first color in the list that qualifies. So you can actually express preference. You can express them in the order of preference.
Is there a way to tell it to just figure it out from the background?
No.
OK.
Because I think that's quite hard because, there's compositing and transparency. So it's actually quite hard to figure out.
Be a bit of a round trip.
At least.
Yeah, OK. Yeah.
And then also it ends up being, per pixel, because if you have a background image, like.
Yeah, yes, it would have to be an average across the element.
Or something.
Oh, OK,
so
OK,
it gets difficult.
fine.
So I think I would rather have this than nothing at all, at least. Right?
Yeah. I'm not criticizing this. I was just, I don't know, looking for ideas for the next thing to work on.
Here's, so it is implemented in Safari, and you can see when it comes to green, it switches the text to black because humans perceive the brightness of green much more than the other colors. And I think that's going to be great. With a lot more color construction going on, this will be super handy. And speaking of that, there used to be a proposal for this color syntax, where you take a color and you have modifier function to make a color lighter, or
like
darker.
the stuff that's in SAS and
Yes.
everything like that. OK.
This is not going to happen
Great.
in the syntax. There's another syntax. But this,
All right.
there's still tutorials out there talking about this. Everybody should know this is not the syntax. It has been removed from the spec. This is not happening anymore. Instead, they actually opted for something more powerful because it turns out, lightness or contrast is not easily talked about if you don't know in which color space you're working.
OK.
So what they're doing instead, and I think this is a really nice workaround, they actually allow you to define a color and say, I want to work in HSL. So use the color from this variable in HSL. And then you get H, S, and L as variables that you can use in calc expressions to do your stuff. And so whatever you choose, whether it's HSL, LAB, RGB, you will get these variables to do proper math on with your calc expression. So for example, if you're an LAB, you can literally just say, OK, add 20% lightness to my color, and the color that comes out will be 20% lighter, which I actually think is quite expressive.
And is that fine even if the input color is not expressed in HSL?
Yes, it will convert. So if you use the HSL function, but the primary color variable here points to something that is defined in P3 or LAB, the browser will do the conversion, give you the variable values, probably do the clamping if necessary, and you can do math. And that will allow you to do stuff like define some primary colors, and everything else could be computationally generated, both the color contrast for the text colors, but also lighter shades, darker shades. At some point, I do envision that we will actually just define some primary colors for dark mode and light mode, and the rest is programmatically derived
Very nice.
from those colors, which sounds like a great kind of future to me.
Yeah.
Yeah, so if you want to know more, this was like a speedrun of what is in CSS Color 4 and 5. Most of it is in Safari, coming to Chrome, hopefully in Q1 2022.
All right.
Who knows? I'm looking forward to it.
I am too. So what you want to? I mean, come on. say your words, and then we can get out of here.